Hello, everyone. Welcome back to our channel. I hope you're having a fantastic day. Today, we're diving into the fascinating world of artificial intelligence, specifically focusing on a concept that's crucial for anyone looking to understand how AI works, the AI model pipeline. So, if you've ever wondered how AI models are built, trained, and deployed, you're in the right place. Now, here's a key question to ponder. What exactly is an AI model pipeline, and why is it important? Well, think of it as a series of steps that guide the entire process of creating an AI model. Just like how a factory assembles a product, the AI model pipeline is a structured pathway that ensures we build effective and efficient models. Let's break it down step by step. The first stage of our AI model pipeline is data collection. This is where it all begins. Without data, there's no AI. Imagine you're trying to teach a child what a cat is. You would show them pictures of cats, talk about their characteristics, and perhaps even let them interact with a cat. Similarly, we collect data to train our AI models. This data can come from various sources like databases, web scraping, or even user-generated content. For instance, if we wanted to build a model to identify different species of flowers, we would gather a diverse dataset containing thousands of images of flowers, alongside labels that tell us what species each flower belongs to. The more diverse and comprehensive our dataset, the better our model can learn. Once we have our data, the next step is data preprocessing. This is crucial because raw data is often messy and not suitable for training. Think of it like cleaning your house before guests arrive. You want everything to look neat and organized. In this stage, we might handle missing values, remove duplicates, and normalize the data. For example, if our flower dataset contains images with different resolutions or formats, we would standardize these to ensure consistency. We might also apply techniques like data augmentation to increase the diversity of our training set by modifying existing images slightly, like rotating or flipping them. This gives our model more examples to learn from and helps improve its performance. Now that our data is prepped, we move on to the model selection phase. This is where we choose the algorithm that will power our AI. There are numerous algorithms available, each with its strengths and weaknesses. For image recognition tasks, convolutional neural networks, or CNNs, are often the go-to choice. Let's say we're building our flower species model. We might choose a CNN because it's particularly good at processing visual data. However, if we were working on a text-based task, like sentiment analysis, we might opt for natural language processing models like BERT or LSTM. Choosing the right model is vital. It can significantly affect the performance of our AI. After selecting our model, we enter the training phase. This is where the magic happens. We feed our pre-processed data into our chosen model and allow it to learn. During training, the model adjusts its internal parameters to minimize errors in its predictions. For example, if our model incorrectly identifies a daisy as a sunflower, it learns from this mistake. Training involves a lot of iterations, and we often split our dataset into training and validation sets to monitor the model's performance and prevent overfitting. Overfitting occurs when a model learns the training data too well, including noise and outliers, which can hurt its performance on new, unseen data. Once training is complete, we move to model evaluation. In this stage, we test our model using a separate test dataset it hasn't seen before. This helps us gauge how well our model will perform in real-world scenarios. We use metrics like accuracy, precision, recall, and F1 score to assess its effectiveness. For our flower classification model, we might find that it correctly identifies 90% of the flower species in the test set, which is a great start. However, we might also discover that it struggles with certain species due to similar appearances. This evaluation phase is critical because it informs us whether our model is ready for deployment or if we need to go back and tweak it. And finally, we reach the deployment phase. This is where our AI model goes live. We integrate it into applications where it can be used by end users. For instance, our flower identification model could be deployed as a mobile app that allows users to take pictures of flowers and receive instant identification. Deployment is not the end, though. We need to continuously monitor the model's performance in the real world and update it as necessary. This could mean retraining it with new data or fine-tuning it based on user feedback. To wrap it all up, an AI model pipeline is a systematic approach that guides us through the journey of building, training, and deploying AI models. From data collection to deployment, each step is crucial in ensuring our models perform well and serve their purpose effectively. If you found this video helpful, don't forget to give it a thumbs up, subscribe for more educational content, and let us know in the comments what AI topics you'd like us to explore next. Thanks for watching, and see you in the next video.